In this question, we are told that codeine, and then we're given the formula for codeine, which is a commonly prescribed painkiller, is a weak base. A saturated aqueous solution of codeine contains 1 gram of codeine in 120 ml of solution and has a pH of 9.8. Given this information, we're asked to calculate what is the Kb of codeine. So what I'm going to do is I'm going to indicate that we have codeine, this base, using the symbol B. And it's a base, so I need to set up the Kb reaction to figure out the pH. So there we are, just like that. And bases, of course, make OH minus. So whenever we're doing an ice table, we're going to be working in moles per liter. So the first thing I've got to do is figure out how many moles per liter of the codeine that I've got. So it doesn't give me molarity, it gives me grams in 120 mils. So we've got to go ahead and calculate the moles of codeine. And that's always going to be equal to your grams over your molar mass. And so I'm going to have to go ahead and calculate the molar mass. So I've got 18 times 12.01 for all of the carbons, plus 21 times 1.01 for the hydrogens, plus 14.01 for the nitrogen, and then 3 times 16 for the oxygens. And that ends up being 299.4 grams per mole. Okay, so once I've done that math, 1 divided by that ends up giving me 3.34 by 10 to the minus 3 moles. Okay, but what we want to do is we need to divide that by the liters of solution in order to get the molarity. So I've got 120 mils, or 120 by 10 to the minus 3 liters, and so my molarity is just going to be the answer that I got before divided by 0.12, and then that ends up being 0.0278 molar. So that becomes my initial concentration of my codeine, 0.0278. This is irrelevant, and these are 0 and 0 before it comes into equilibrium. Okay, so now let's go through and see if we can solve. We're given the pH. It's not very helpful because what we really need is the equilibrium OH minus. But if I do 14 minus the pH, I can get the POH. So 14 minus 9.8 is going to give me 4.20 for the pH, and I know that the OH minus is just equal to 10 to the minus POH, which would be 10 to the minus 4.20. So when I do that, I get my equilibrium OH minus concentration, which was 6.31 by 10 to the minus 5. So at equilibrium, the concentration of OH minus is 6.31 by 10 to the minus 5. So what's going to happen is this comes to equilibrium. It always moves towards the zeros. This will go down by x, so giving me 0.0278 minus x. This will go up by x. This will go up by x. And so what we know is that x equals 6.31 by 10 to the minus 5. So now I can go ahead and calculate my Kb. So my Kb is just my concentration of OH minus, which was my x in this case, multiplied by the concentration of my conjugate acid, BH plus, again, which is just x, multiplied by my equilibrium concentration of my base, which was my 0.0278 minus x. So let's put all of that in. These two guys are the same. The hydroxide and the BH plus are the same, so I'm just going to put that in as 6.315 by 10 to the minus 5 squared. divided by the concentration of my base, 0.0278 minus 6.31 by 10 to the minus 5. It's a weak base, so it should be a small kb. Let's see what we get. And I ended up getting 1.44 by 10 to the minus 7. KBs don't need any units, and that's definitely a small number.